My name is Greg, and today I'm going to talk about various tools that we as a Micro use and extend for the purpose of planning, development, and also verification of digital design projects. So let's start with the basic planning and overview. So usually when you start working on a digital design project, or you want to show some intermediate results or just discuss some things with others, you usually want to demonstrate your design as a diagram so that it is clear view how things work. And for this purpose, you can either draw a regular image or you can use Pipeline Manager. Pipeline Manager is an application agnostic web application that allows creating, visualizing, and managing graph-like data. It is fully data-driven, so you can provide the exact blocks that should be available for building the diagram. You can specify what interfaces, properties, links to remote resources should be present in the graph. And this, over time, allows you to create more and more detailed representation of your project. You can either download Pipeline Manager and start working with it from scratch. You can use it as a standalone website. You can also use it as a Python-based application. And you can also jump right to our system designer, which uses Pipeline Manager and brings a vast database of available hardware components as well as growing database of RTL components. So what you can do is you can basically, let me just zoom a little bit, define some initial project, add some interfaces to it, and modify it as you need, and add more data over time. Next tool for planning that we have used is Test Planner. Originally, Test Planner was implemented in OpenTitan. We extracted this as a standalone module and enhanced it to provide better integration with the documentation and also simulation results. It allows you to define test plans for your digital design project in the form of a HJSON file. So you can define the name of the test plan, you can specify the test points. Within the test points, you can tell exactly what is the intent, what is the stimulus and check that you want to, that is supposed to be verified by this test. And then you can also specify names of the tests that are actually run, for example, during simulation. And once you have such JSON files in your project, you can easily generate summaries of your tests using Test Planner applications. So you can either create a Markdown documentation or HTML documentation, as well as you can, for example, generate a spreadsheet which provides detailed information on the progress and also intent and other data described in the description. Next, let's talk about tools for design development. And here, the first tool I'd like to cover is TopWrap. Now, TopWrap is an open source design aggregation tool that allows you to efficiently combine, organize, and manage design IP components. It promotes modular configurable approach where you subdivide your design into build blocks that you can later use to form a top-level module. And you can just take and parse your Verilog files and create blocks that can be later loaded in TopWrap using TopWrap GUI, which is powered again by Pipeline Manager. So when we go back, here we have our initial design, and that was just a concept. Now we can grab the existing the existing design files, and those can be depicted like so. So here we have actual cores with some simple I3C and VIR-L2 core, and so on. So as you can see, we can get more and more detailed view on what's going on in our design. Next tool that is worth mentioning is PickRDL. It is an open source Python-based system RDL toolchain that allows you to define your registers using system RDL files. And from this point, you can easily generate RTL files, header files, documentation, and also Renode functional simulation for registers, which will be covered a little bit later. Okay, so we have some tools that allow us to generate design code. Now let's go to tools for validation. Here, the tool that I would like to cover is UVM DVGen. It was also originally developed in OpenTitan and extracted as a standalone module by us, and we also applied several changes to make it more generic. And what this tool does, it allows you to generate generic and repeatable code for UVM agents, test benches, and also environments. It is highly configurable, so you can specify what kind of IPC core you want to cover, and you can tell that you want to generate the agent code for that. You can specify whether the design has alerts or it has interrupts and so on. You can even specify the license header that you would like to use in your generated source code, so that in the end you get a set of files that act as a base for your UVM test development, and it lifts from you the necessity to create all of this on your own. When you have verification and initial design, you want to either test your design in simulation, or you want to just run it to demonstrate how it works. For this purpose, in some cases, you want to verify the specific part of your design. For example, I3C, where we have also some CPU, UART, and memory. So you could obviously run the whole RTL design, but it would take quite a lot of time. So to address this, you can significantly speed your simulation up and also replace non-existing blocks with some functional simulation using Renode framework. It's open source, full system functional simulation framework that allows you to replace certain blocks with functional models. It is a functional simulator that you can connect to, for example, Verilator using DPI interface. So that's for simulation. Now that we have some test results and we have design and we have initial plans for tests that we wanted to follow, we want to test how does planning correspond to actual development. For this, again, we can go back to Test Planner. In Test Planner, we can provide simulation results in the form of HJSON file. So we can specify the name of the test that was executed, whether it passed or not, as well as we can provide simulation time, actual processing time, and also, for example, location to the file. In case location is not provided by the test framework, you can easily provide your own mapping from test to their implementations using source map flag, which accepts the YAM file that provides a pretty powerful regex-based search for implementations. For example, for CocoDB, everything is provided out of the box. You can just use CocoDB XML to HJSON to generate necessary files. So in the end, when you have your test planner, you can have your documentation where you have some test results. You can jump to those test results, observe which ones are passing and which are not. You can also go back to the documentation, and you can also jump to the implementation for the specific test, and it will point you right to the test that was executed. Next up, we have CoverView, which is a tool for verifying the coverage of your design based on your tests. So it is totally language agnostic, and it takes data from info files. You can just take info files and aggregate them to generate the final coverage report, and later you can use it like so. So here we have the coverage for the entire design. Let me just zoom a little bit. You can jump to specific directories and observe the coverage. And in the end, we can have a complete design overview, which basically combines all of the above to form a comprehensive view. And for this, use, again, Pipeline Manager paired with SVLang, and also other tools like CoverView and etc. So what you can do now is you can see the full design. You can jump to its implementation, so you can see what submodules does it consist of. You can jump to the sources of your design, and you can also jump to coverage. You can also preview it right here. So as you can see, we can get linked to basically everything, including also test plans. So this is everything interlinked in your documentation. Thank you very much.
Right on spot. Do we have a question?
Questions? That was just a quick comment. I quite enjoyed that. It was a lot of like very interesting tools, you know, all linked together. Looked like very practical.
So in the graphing tool, can I add hierarchy? I find that in these graph-based tools, as soon as you go over like, you know, 6 nodes, you just get lost in the spaghetti, and I just want to bundle things up into subsystems. Is that something you can do from within the tool?
Sorry, could you repeat?
If there's hierarchy.
Can you add hierarchy, or is it just the spaghetti of all the modules you link together?
It's a hierarchy. So when you see
okay.
here, you can you have the this is the top module basically, and then you can jump to specific implementations of those modules.
Right,
so
thanks.
They can be.
So let's thank the speaker again.
Hey, thank you.
Thanks, Chris.